Alright, let's get into another video, and this video is going to talk about functions in C++. Now, in C++, you are able to create your own functions, or commonly referred to as declaring your own functions. And we've actually seen a function before, and that is the main that we are familiar with. So technically speaking, main is a function in C++, and it is the only function that is called automatically. Now, when we make a function, you would typically follow a similar format like we do with the main, except you have something like my function. Again, you'd have these parentheses. And if you look online for an example, you might see something like void, my function with the parentheses, and then these squiggly brackets. And inside these squiggly brackets, that's where all of your code is going to go. But this void right here might be a little bit confusing. And our only other reference is the main. So what does the discrepancy mean here? Well, void means that the function does not have a return value. And then later on when we scroll down the whiteboard here, we'll actually see that we can replace void with other things like int, float, double, or we can just keep void. Now maybe you're asking yourself, where do I put these functions in the code? Does it go in the main? And how do I call these functions to actually use them? For that, we typically define functions outside of the main in their own blocks, but we can actually call for a function in the main, or you can call for another function inside of a function. So it's worth noting that functions can be called multiple times. Now we have something called parameters for these functions. So think of this like passing info for the function to use. So if we look at the generic void my function, and then we have parameter 1, 2, and then it goes all the way to n. These parameters are going to be variables inside of the function. Now we do need to define the data type of each one of these parameters, so that would be something like int, string, again float, double, or whatever you need to put in for that data type. So if we go into Visual Studio, and here we just have a very basic function. So we are going to be using the input-output stream. We're going to be using windows.h. The reason for that is because I like to use this sleep function. If this is the first video you're seeing in the playlist, watch the previous videos for that sleep function. But here we have our main, and then we have our function above. So inside of the function, we're not returning anything, so we're using that void here. But what our function does is it outputs that your function has executed. But now we are starting to get a little bit more technical, and if we just use that cout command, we're really not storing anything in an output, we're just printing characters to a terminal. So here's our pretty basic function, and then if we look in the main, which will be executed automatically as soon as we run that code, we are just going to output loading the code, please wait. And we're going to sleep for 2 seconds, or delay for 2 seconds, and then right here, we're going to call that function. And then after that function, we're just going to return 0 to show that everything executed successfully. So if we run that code, so you can see that it said loading the code, and then it had some delay, and then our function has been executed. But now if we return to the whiteboard, we can look at a little bit harder of an example. So what we're going to do is we are going to write a function to find the square root of a number. And the method that we're going to use for that square root, that's going to be the Babylonian method. So we're going to have some number that we want the square root of, s, and we're going to take an initial guess at what that square root is. So the formula that we use is simply given by x1 is equal to that initial guess plus the number we want the square root of, divided by that initial guess, and then we divide all of that by 2. And then, as we will soon see, there is some tolerance comparison to determine if we need to keep iterating, and we end up at the iterative formula given right here. So if we look at an example, let's say that s is equal to 23, and we want to find the square root of s. And of course, for all of these square roots, you get a positive and a negative root, but in our case, we're only going to be concerned with the positive root for now. So just from some basic math, we know that 4 squared is 16 and 5 squared is 25, so we would expect the square root of 23 to fall somewhere between 4 and 5. But for our initial guess, let's just say it's 4. So if we now plug in 4 to the iterative formula that we had right here, actually we can just use this for the first case, we'd see that x1 is equal to 4 plus 23 divided by 4, and that whole quantity divided by 2. And that's going to be equal to 4.875. Now what we can do is just automatically iterate that for this example. So we're going to plug that 4.875, and that's going to allow us to find x2. So now we just use that 4.875 instead of 4. So x2 gives us approximately 4.796. We can iterate that once more, and x3 will give us approximately 4.7958. And then if we try to find x4, now using x3, we get that that is also approximately equal to 4.7958. But we soon arrive at a little bit of a conundrum, and that is, when does the iteration stop? Because theoretically, x sub n could go all the way to x infinity, and it would never stop, and our accuracy would just keep getting better and better. So what we can do is define some tolerance. And what you really need to do is decide when that approximation should be good enough. Now, because we determine the amount of precision we need, we can arbitrarily choose that tolerance to be plus or minus 0.001. So we could terminate the iteration process at x4. So if we think of how can we do this in a function? Well, we know that we need to take the number that we want the square root of and the initial guess. We need to take that from the user. We also know that we need to use this iterative formula here. And then after we use that iterative formula, we need to compare x1 and x0 from some defined tolerance. So there are two ways we can define that tolerance. You can define it inside the function, or you could actually take another input into your function where you specify what you want the tolerance to be. In this case, we're just going to define it in the function, as we'll see once we get into Visual Studio again. And from the example earlier, we saw that you could print the answer inside of the function, or you could have that output of the function go to some defined data type. In this case, it would probably be a float, and that would go in the main. And inside of the main, how that would look, well, we would just define some float, and then we would have something called answer. It could be whatever you want to call it though. And that would be equal to the function that we call. But now we probably can't use that void here because we want to return something. If we return nothing with void, well then nothing would theoretically go to this float answer. And to actually extract that output of the function, we have to use the return feature. Now, if we look into what return does in the function, well, if we just use cout, as we talked about before, it just prints to the console, so we're just displaying characters. But return allows us to receive the result that's going on inside that function, and it kind of gets stored in the background. But then in the main, we can print out that result simply by storing what gets returned from the function as a variable, and then displaying that variable. Now, if we go back into Visual Studio, where we made a different function, now notice here we are including CMath. And the reason we include this is it allows us to use a line of code that lets us find the absolute value of a floating point number. Now, if we look into our Babylonian square root function, we are simply going to have two variables. So we're going to have some float, that's the number we want, and then some float that's going to be our guess. And then we're just going to define some variable here. So float as next guess, just so we can use that variable later on. Now here we have our do while loop. So we're simply going to say next guess is equal to guess plus number divided by guess. And that whole thing divided by 2. That's our Babylonian formula. And then here's our if statement. where we are looking at the absolute value of the difference. And the reason we use that absolute value is because, well, we can set our tolerance to plus or minus 0.001, and we can modify the code like that, but this also introduces this CMath. And if we are within this tolerance, we're just going to break out and exit this do while loop. So then our next line of code is this return next guess. So if we make a really good guess and we're within this tolerance, well, this next guess right here that's already defined, we're just going to return that. Otherwise, if we are outside of that tolerance, we don't even consider this if statement, and we just say that guess is equal to next guess, which is defined up here. And then we keep doing that because our condition while true, well, we're not going to be violating that anytime soon. So if we look now into our main, notice here we have float s, which is our number that we want the square root of. We have our initial guess, x sub naught. And then automatically, this code is going to run, please enter the number you wish to find the square root of, positive only. So whatever you type into the terminal, that's going to be stored as s. And then we are going to approximate what we think the square root might be. So integers are fine, but we could have a floating point if we want. And that's going to be stored as x sub naught. So now we're going to call our function. And the result of our function, we are going to store in the variable answer. And the function we're calling is what we defined above. And notice here we are using s and x naught, which is what we defined up here. So notice that s and x naught is not named the same way. Right here is number and guess. And that's perfectly fine. You don't have to match those variable names. It's just going to take whatever this first variable is, and it is going to throw it into number, and then whatever that next variable is, it's going to throw it into guess. Now also notice here, in this function, we are returning a float. So we're not using a void because we're going to return some value, and that value is going to be stored in the variable answer. Now after we call that function will run, it'll get us some value, and then it will store that value, and after that whole process is done, we're simply just going to output that the square root of s, so whatever we entered for our number, that's going to be approximately equal to the answer. And the answer here is the output of our function that we called. So what we can do is run this code. So down here you see please enter the number you wish to find the square root of. So let's say 23, and let's guess 4 as we did in the example. If you learn anything new, please like, comment, share, subscribe. Helps the YouTube algorithm. Thank you for watching.